Okay, this is the second half of section 4.7, so we're going to be doing composition of trig functions now. So it's still the idea of using inverses that we did in the first section of 4.7, and now we're going to be doing composition, which is stuff that we did first semester. So whenever we're doing composition, one function inside of the other, we always start deep. So start in as far as you can go. So I see that the negative 1/2 is the deepest that I can go, so I go out to the first trig there. So it looks like this is going to be the first thing that we have to deal with. Well, it's an arc, which means that's equal to theta. So the first thing I'm going to do is I'm just going to take a look at the stuff inside. So arc cos of negative 1/2 is equal to theta. All right, now it just looks like a problem from the first part of this section. Cosine of theta is equal to negative 1/2. Is that possible? Yep, sure is. Cosine, remember, it needs to be between negative 1 and 1. Negative 1/2 is definitely in there. All right, started out as an arc, so we got to restrict this thing. Arc cosine does not exist in the bottom. I also know that I don't want to be where cosine is positive. So that's definitely not over here either. So let's get rid of that area. So where cosine is negative, cosine is going to be the x value. So I want the x to be kind of short. So I think we're right there. All right, so figuring out what that angle is, so I need to go this way. And it looks like it's going to be at 2 pi over 3. So I think theta is 2 pi over 3. All right, so now what I'm going to do is I'm going to plug this in right up there. Let's go back to the black pen. So now I'm going to do cosine of, that's where the theta was, plug it in. And then cosine of, my theta is 2 pi over 3. Well, this is something that we should be extremely familiar with. That's negative 1/2. So my answer is going to be cosine of arc cosine of negative 1/2. Just give me negative 1/2. Worked out kind of nice. Why did it work out? Well, because cosine and arc cosine are inverses of each other. And whenever we put an inverse next to itself, or excuse me, we put a function next to its inverse, they cancel. But you have to be careful because it doesn't always work out as easy as that. Sometimes you have to do a little bit of work. So in this case, because the negative 1/2 was nice and pretty and it worked out perfectly for us, we could have just canceled them. But better safe than sorry, I'm going to go ahead and do a little bit of work. All right, so now let's take a look at question number 2. I'm going to do it the long way, and then we'll talk about why. So I'll do the stuff inside. That's an arc, so I'm going to set it equal to theta. So basically, I've got arc sine of 3 is equal to theta. I'm going to rewrite that. So sine of some angle is equal to 3. I ask myself, is this possible? No. It's a resounding no. This is not possible. Sine can only achieve a true maximum of 1, and 3 is well past 1. So this does not exist, which means the original question, although the sine and the arc sine are inverses of each other, you can't just cancel it out and say the answer is 3. And that's because sine can't ever achieve the value of 3, unless there was some sort of a stretch in there. But there's no stretch. This is just plain old sine. Okay, number 3. All right, so let's stop and think. This basically says, just do a little bit of thinking here. This basically says that tangent of some angle is 7. Is that possible? Yes, it's definitely possible. Tangent has no restrictions on it. Tangent can do whatever it wants. So can so can cotangent. So because this is possible, I'm not going to do any work. I'm just going to do more thinking than anything else. Because this is possible, and this cotangent and this arc cotangent are inverses of each other, I am just going to go ahead, cancel out the tangent and the arc tangent, and I'm just going to write my answer, which is 7. No work, definitely thought though. Okay. Number 4, so let's see if we can think about this. I see that I have two things that are inverses, arc sine and sine. I'd love to cancel these out. I just don't know that I can. So I'm going to think about the angle itself. So I'm going to go off to the side, and I'm going to draw where 5 pi over 3 is located. And I know that 5 pi over 3 is down here. It's this angle. My question is that an acceptable radian for arc sine? Because there's an arc here, I got to deal with that. Is this acceptable? Well, I don't know. Let's put the coloring in. Sine has a restriction. Oh, this doesn't look very good. You're not allowed to go through there. Notice that the curl on my angle for 5 pi over 3 goes through the purple area, which we know is a restriction for sine. So is there some way, is there some other angle that still gives me the same sine value but doesn't go through the purple? Yeah, there is. Notice that where this is located is not a problem, just this regular location of where that angle is. Notice it's not in the shaded area. We just have to find another way to get there without actually curling through the purple. I propose that we go this way instead. This angle here is going to be negative pi over 3. Notice it still gives me the same sine value. So let's go through and rewrite this. So I can replace 5 pi over 3 with negative pi over 3. They're coterminal angles, so the sine at those locations are going to be identical. Now, this and this can cancel because the negative pi over 3 is acceptable. So my answer is just going to be negative pi over 3. Notice that it is not 5 pi over 3. 5 pi over 3 would be the incorrect answer because 5 pi over 3 goes through the shaded area or the restriction for arc sine. So negative pi over 3 is the only correct answer to this question. Okay, number 5. All right, so let's stop and think. We've got arctan of tangent. Okay, so I've got inverse functions, 3 pi over 4. All right, so let's graph 3 pi over 4 off to the side. 3 pi over 4 is here, and it is this angle. All right, well, we've got a tangent restriction, so an arctangent. Well, arctangent, we've got some big problems here. That's the restriction. Notice that not only do you land in a bad spot, but you go through the bad spot too. So this is not good. Now there's a couple ways that you can do this. I think I'm going to do this probably the longer way, but just to make sure that you understand. So we're just going to go through and evaluate stuff. So the first thing that I'm going to do, so I'm going to evaluate this. So let's go ahead and evaluate. Because there is an answer to this. It's just not as obvious as we would like it to be. So tangent of 3 pi over 4. All right, well, tangent of 3 pi over 4 is going to be negative 1. All right, so now we can go ahead and plug this in there. So now I can do arctan of negative 1. All right, so now this is some theta. All right, so tangent is equal to negative 1. Now take out my restriction again. I can't be over there. Out of the two quadrants that are remaining, tangent is going to be negative down here. That is the theta that I'm looking for. I think that is going to be negative pi over 4. So theta is going to be equal to negative pi over 4. which means my original question, arctan of tan of 3 pi over 4 actually is equal to negative pi over 4. So taking a look at these two pictures. So although 3 pi over 4 landed in the second quadrant, I'm not allowed to use it because it lands in the restricted zone. So I went through and evaluated it the long way and found that I could still get a same value for tangent down in the fourth quadrant. Why does this work? Well, because of the ASTC information I told you guys a while ago. Remember, all sine, tangent, cosine. All sine, tangent, cosine. If we take a look at this, notice that in the first picture we're up in the sine quadrant, which means tangent is going to be negative there. So the question is where else is tangent going to be negative? Well, tangent's also negative in the fourth quadrant, the C quadrant. Just as long as it's not in the first and the fourth, it's going to be negative. So although it doesn't land where I want it to, I can go through and still evaluate it. Just like I can get rid of, any twisting through the restricted area, I can actually eliminate landing in the restricted area as well. All right, number 6. This is definitely not something with the unit circle that we're familiar with. So we'll go ahead and take this stuff on the inside. It's an arc, so let's set it equal to theta. So I know that arc cosine of 2/3 is equal to theta. So what does that say? So cosine of some angle is equal to 2/3. All right, but it started out as an arc. So let's go ahead and get our little restrictions out. Cosine can't be down here. All right, out of those two quadrants, cosine's going to be positive in the first quadrant. So I'm here somewhere. I don't know where though, because 2/3 is not something I'm familiar with. So what I'm going to do is I'm going to redraw that picture. I'm going to give myself an actual triangle. So there's my theta, and it says that cosine is 2/3. So adjacent is 2, hypotenuse is 3. All right, I drew the picture. There it is. Now I want to find tangent of that angle. All right, so take a look back at the triangle. For tangent, I have to know opposite and adjacent, so I need to do the Pythagorean theorem. So I'm going to do 3 squared minus 4 squared, so 3 squared minus 2 squared. 9 minus 4 is going to give me 5, so I think this is going to be the square root of 5. Now, let's just look at the picture. What's tangent in that picture? Well, tangent is going to be opposite over adjacent. So although it's not something I'm familiar with from the unit circle, I can draw a picture, create a triangle, and actually answer the question no problem. So tangent of, let's do my original question, arc cos of 2/3 is that root 5 over 2 that I just got. It doesn't necessarily have to be something that you're familiar with, but it is based off of knowledge that you already have. Okay, number 7. All right, so it looks like we have stuff that aren't inverses and stuff that isn't necessarily from the unit circle. So number 7, same idea. Let's go ahead. This is an arc, so let's set that equal to theta. So I know that sine of some angle is going to be negative 3/5, but it started out as an arc, so make sure that you restrict. For sine, it can't be over here. If it's going to be negative, we need to be down. I'm going to go ahead and draw a triangle, because this is not something I'm familiar with. Sine is opposite over hypotenuse. May as well find the side next to it as well that's missing. And I don't really have to do much thought here because I know that 3, 4, 5 is a Pythagorean triple. So I've got my 3, 4, 5 filled in. Now I can take a look back at the question itself. So I want to do cosine of that angle. Okay, so I created the angle. Now my job is to find cosine of that angle. Well, cosine is going to be adjacent over hypotenuse, which looks like it's just going to be 4/5. So my question, which was cosine of arc sine of negative 3/5. And it looks like I got 4/5. Okay. Number 8. All right, well, 8 has an x in it, which means now we're just talking about a general case. So, got the same idea here. This is an arc cosine, which means that is going to represent my theta. So I know that cosine of some angle theta is going to be equal to 3x, and let's give it a denominator. So let's put a 1 underneath it so we can actually see an adjacent side and the hypotenuse. All right, so I've got a restriction. So let's take out our little picture here. Arc cosine can't be down. Out of these two quadrants, well, this is a positive ratio. 3x over 1 is positive, which means I am talking about a positive cosine. So I'll draw my triangle. Cosine is going to be adjacent over hypotenuse. All right, got to do the Pythagorean theorem, so it's going to be square root of hypotenuse squared minus leg squared. So make sure that you square the 3 and the x. All right, so now I want to do sine of that picture, basically. So sine of the picture theta that we just created is going to be the square root of 1 minus 9x squared over 1. Well, you don't need the 1, though. So our original question, sine of arc cos of 3x, and we're going to get the square root of 1 minus 9x squared. So again, in the last couple problems, we just draw the situation so that it's appropriate. This isn't necessarily something we're familiar with from the unit circle, but if you can draw it, you can do it. All right, number 9. All right, so definitely not something I'm familiar with, but there's an arc, which means that's a theta. So we're going to draw some picture to represent that situation. So tangent of something is going to give me negative x over root 5. All right, well, this ratio is negative, so we've got to keep that in mind. So take out our restrictions for tangent, or for arc tangent. Out of those two quadrants, to be negative, I'm going to have to be down. So let's draw a triangle down here. Tangent is going to be opposite over adjacent. All right, and then we have to find the hypotenuse. So right here, it's going to be the square root of leg squared. Well, negative x squared is actually x squared, plus root 5 squared, which is just 5. All right, now I've got the picture, so I want to do secant of that picture. Well, secant is the reciprocal for cosine. Cosine's adjacent over hypotenuse. Let's do hypotenuse over adjacent. So hypotenuse over adjacent. All right, now, if we take a look at this, this is really not the prettiest thing in the world. When are you expected to rationalize? You are expected to rationalize a denominator if the denominator only includes numbers. If it has a mixture of numbers and variables, or if it just has variables in it, you don't necessarily have to. So, if I take a look at this denominator, the denominator is just a number, which means I have to rationalize it. So I'm going to multiply top and bottom by root 5 for this. Notice on the top, everything is inside roots, so you can actually just do one big root and multiply the stuff. So 5x squared plus 25 over, and then root 5 times root 5 is just 5. So my question, which was secant of arctan of negative x over root 5, and I got that mess above, square root of 5x squared plus 25 all over 5. All right. And then number 10, which I think maybe is the last one in this section. So I take a look at this. I've got an arc on the inside, which means that is going to be my theta. So I'm going to draw some picture to represent this situation. So cosine of theta is equal to that m plus h over 3k. All right, the ratio is positive. I have no reason to believe that this is negative. So I take out the restriction. Cosine can't be in the bottom. This is going to be positive, which means I'm in that positive quadrant. Draw a fairly large triangle just because I've got some big stuff to put in it. There's the theta. And I know that it's going to be adjacent over hypotenuse. Okay, so now I have to find this side here. So this is going to be the square root of hypotenuse squared, oh, right on the edge, minus leg squared. Let's actually move this down. Draw a little arrow here. So that is going to be the square root of hypotenuse squared minus leg squared. And you don't have to multiply that out, actually. Don't do it. So if you do, you make a mistake, then it's going to be wrong. So now we want to do tangent of that picture. Okay, so tangent is going to be opposite over adjacent, which is going to be that big square root, which is going to be 9k squared minus m plus h squared over adjacent, which was m plus h. So our answer, go back to the original question, it's going to be tangent of arc cos of m plus h over 3k is equal to that mess that we just found. Square root 9k squared minus m plus h squared all over the m plus h. I don't even have to think about rationalizing this because there are no radicals in the denominator. And that does it for 4.7.